Welcome to this course on AWS development, Amazon Web Services development. My name is Savitra and I'll be your instructor throughout this course. All right. And then we'll get into today's agenda, which is to basically introduce you to cloud computing and also introduce you to Amazon Web Services. So this introduction is important so that, prepare you, right? You are prepared to really get into AWS, to start using AWS. So just a high-level conceptual introduction to cloud computing and AWS. All right, so this will be the agenda. So first of all, let's discuss the course structure, the modules that we have. But first, let's talk about the course structure. All right, so as you know, right, so this is something you'll know. Basically, this is a 12-module course, and each module is 3 hours, right? And first couple of modules, overview, right, fundamentals of cloud, and also that of AWS. And this is to prepare you for what's coming next, right? So that you have a high-level conceptual understanding of these things, and then we can actually start using AWS. On the server side, I'll be using Linux. I'll be using Ubuntu, right, in most cases. Sometimes I may use something else just to show you some differences. So again, like I said, if you're more of a Windows person, you may find this course difficult. If you're happy to learn Linux, then great. So on the server side, we'll be using Linux. A lot of the commands that I run, that I show in the demonstrations will be on Linux. And I'll be showing you some code samples, right? It's not a very big part of the course because this is an infrastructure course. So although it's for developers, we'll not be developing too much of code in this course. But whatever I show you, I'll show you using Ruby. And but you can easily sort of translate that into your own programming platform, right? So if you're a Java person, if you're a .NET person, PHP, you can easily follow or do the same thing in your application, right? So I'm not concerned about Ruby and the fact that you may find it difficult, but I am concerned about Linux. So Linux will be heavily used, all right? This is how we will work. And so what we'll look at is, first we'll look at what is cloud computing, right? How can we define it? What does it really mean so that we have some context around this course? We'll talk about some deployment models. Right? So this is, what is a public cloud and what's a private cloud? There's also something called hybrid cloud, right? So this is important to understand because some of the AWS services are public, some are private, and a lot of people use AWS in a hybrid manner as well. Then we'll talk about some service models in the cloud computing industry, right? So these are 3 main models: software as a service, PaaS, platform as a service, and then infrastructure as a service. Right? So we need to understand the differences between these 3, and we also need to understand what AWS is. Right? What does it give you really? And once this is done, we'll look at AWS itself. So what does it offer? What can it do for you? Where will you use AWS? We'll look at the infrastructure that AWS has. How is it organized? Geographically, where are the data centers, which geography you should use within a data center, what are the different components. So we'll discuss all that. We'll spend a little bit time on the industry. So where does AWS stand with respect to competition, for example? Because this will help you understand, is this a technology which is for the future? Should you really invest your time and money learning and using this technology? We'll also talk about how do we access AWS. So there's a web console, there's a command line toolkit, there's also SDK. So we'll discuss how we on these things, and we'll also talk about pricing because there's a lot of concern around pricing, right? It's like AWS pricing and AWS billing is like your mobile phone billing. So postpaid mobile phone billing. So sometimes you can be surprised by the bill, like we all probably have been. So in the telecom industry, there's a term called bill shock. So maybe you were traveling and you suddenly get a very high roaming. So those things happen, and something similar can happen with AWS. Because it's pay-as-you-go pricing, you're billed on a monthly basis, and you don't want to be surprised with a large bill. So this is the agenda for today. So let's talk about cloud computing first. All right, so I'm going to use another slide here. All right, so this slide, I like this slide because in one single page, it shows you a good and a complete definition of cloud computing. So let me just quickly explain this, and then we'll have a discussion. First of all, we'll talk about what are the key attributes of cloud computing. And how is it different from the traditional data centers, traditional server rooms? Then we'll talk about service models, and then we'll talk about deployment models. So attributes. So first of all, cloud computing basically is sharing of resources. And these resources are basically servers, storage, networking, and they're all, these resources are in very large, right, extremely large data centers around the world. And all these data centers are shared by thousands and tens of thousands of companies and developers and enterprises. So basically the idea is it's a very large pool of resources which is shared by many companies. So it's very much like your Uber car sharing. So why do you need to have a car, right? Why do you need to own a car? Let's just have a pool of cars and share it. So this way, everybody gains because your cost of using that car comes down very, very significantly. So same thing with infrastructure. If you have a large pool and if you share it, the cost will be extremely low. And when we share, what we mean is, you can rent a server for an hour. If you want, you can rent it for a longer time as well, for a year, 5 years, 10 years, whatever. But if you like, you can also get a server for just 1 hour. So all this was not possible before. All right, so that's one. Second important point is what is called elasticity. So elasticity refers to, say you have a rubber band, so you can just stretch it and extend it. You can also, release it so that it comes back to its smaller shape. So with cloud, what happens is you have a very quick change in your infrastructure. So let's say you have 10 servers and you have some festival sales coming up for your e-commerce platform. You want to go from 10 servers to 100 servers. You need 10 times the capacity for maybe a few days in a year. So all you have to do is with a few clicks, you can go from 10 servers to 100 servers. But you can even go to 1,000 servers, 5,000 servers. All that is possible. So and it's very rapid, right? So once you click and say, I need 100 servers, very soon, in a few minutes, you can have 100 servers. In the same way, you have elasticity in the other direction as well. So with a few clicks, you can go back from 100 servers to 10 servers, right? So this sort of elasticity is possible with cloud, which was not there, of course, in the traditional purchase cycle or the traditional data centers. So for example, some of you may have purchased servers, right? You may have bought equipment for your company. Now their process is usually put out a request for proposals, you receive some quotations from vendors, you do a comparison, you have some negotiation, and then you place the order, and then the items are shipped to you from all over the world. And then it's weeks before you get your servers. So it takes a long time, but here you can see it's just a few clicks and you get your infrastructure. Now on the other side as well, in traditional data centers, once you bought your equipment and if you didn't need them, there was no recourse without being used, and it would be a big waste of money. But here that's not the case. If you don't need something, you can just give it away. You can terminate those instances, that capacity goes back into the pool, someone else will use it. So when you give away your infrastructure, you are not billed. Your billing stops once you terminate your instances, right? So this is an extremely important point. It's so much better than it used to be, right? And this is one of the reasons why cloud computing is such a big trend. The other thing is the billing, right? How do you charge for using cloud computing? So in the olden days, or even today in many cases, what happens is when you bought your servers, you normally would pay upfront. So you'd pay thousands of dollars for, let's say, an HP Blade server or something like that, an IBM machine. And then you'd have an annual maintenance contract, which would, again, be paid upfront normally. At the beginning of the year, you would pay the annual maintenance contract. Now with cloud, that has completely changed, right? So what you do is it's more like a mobile phone bill. So in a mobile phone, you have, say, an itemized bill. So you did an international call, there's a different price, and then that price is multiplied by the number of minutes that you made the call for. You may have a different roaming price for making calls. You'll have SMS cost, international SMS cost. Services available from your mobile phone provider, operator, and there's a different price for each service, each type of service. And at the end of the month, you get a bill, which is basically the price into usage metric. How many minutes for a call? How many SMSs did you send? So there's a way to measure each service, and then that measure into the price of that service makes up your bill. So with cloud, it's something similar. So if you use micro servers for 10 hours, so there's a price for micro servers multiplied by 10 hours becomes one item in your bill. Storage, there may be a price for a GB per month. So if you use 100 GBs in a month, you get billed for those 100 GBs. That's how the billing happens. So it's pay as you go. The more you use, the more you pay, right? And the less you use, the less you pay, right? So these two are important points. And then, of course, this is also very important. It's on demand, it's self-service. There's nobody, you have to contact. You don't have to phone up anybody. You don't have to wait for anybody. You just go log into your console, click a few buttons, and you get what you want. So this really helps with agility, your business agility. You can move much faster. You can learn faster. You don't have to wait for, because you don't have an environment, you can't learn. You can't test your product. So all that is gone because you can just do it yourself. And also, if you need a server, it's not, nobody will tell you, no, we don't have capacity, because it's such a large data center. It's a seemingly limitless pool of resources. Whenever you need something, you will get it right away. Okay, and the last bit is, access. So a lot of times in the olden days, the data centers used to be available only from your corporate network. So if you were at home, you didn't have access to your servers. That's how it used to work. Now with cloud, what happens is you have access at any time, anywhere. All you need is an internet connection. So this also is very, very helpful because anybody can access it and you have the flexibility, right, of anytime, anywhere access. Okay, so these are some of the key attributes of cloud, and also, how cloud is better than traditional data centers. In Ruby, code that we look at is pretty a small part of this course, number one. And two, we only focus on using the SDK, the AWS SDK, and the code snippets you'll find in Ruby and Java are pretty similar, I would think. So code samples, etc., are not very large, and this is mainly AWS course, right? Our focus is on the infrastructure side, not on the code or app, right? So I think this will not be a problem based on my experience with other batches as well, right? I am more concerned about the Linux versus Windows side because we use a bit of Linux in this course, right? So I'm more concerned about that. I'm not concerned about Ruby here. So is Ruby something I need to install on a Linux box created with AWS account, or would it already be there? And if it's not installed, will there be documentation? Yeah, so don't worry about this at all, right? So as we go through this course, you learn how to install packages. There are things like armies, where Ruby can be pre-packaged. So basically, there's something called AMI, Amazon Machine Image, where you can have, let's say, an Ubuntu server alone, or you can have an AMI which has Ubuntu plus Ruby. So there's lots of ways of doing this, right? So don't worry about this. And we will also see during this course on how to install packages. We will look at some package installation as well. I'll also be using a PHP application in some of the demonstrations. So we'll learn how to install PHP packages and stuff like that. And also in general, AWS documentation is very, very good. Like I said, since you're comfortable with Java, forget about Ruby, right? I'm just going to show you some stuff in Ruby, but you can do the same things in Java. I suggest don't learn Ruby, just follow it as a demonstration, right, and then do it in Java. So now let's look at the next part of this definition, right? We're talking about cloud definition. So we've looked at the key attributes. How is cloud different from traditional servers, traditional data center? Now let's talk about what is called service models. And the idea here is cloud computing is a big industry, right? And it's a big term. It consists of a lot of different things. Right? So cloud computing has things like SaaS, PaaS, and infrastructure as a service. Right? So let's understand these things because we need to understand what AWS is, right? And where does it fit into this definition. So SaaS is basically something which targeted at end users. Platform is targeted at developers, and then infrastructure is targeted at developers, system administrators, and things like that. So firstly, the audience is different for each service model, but all of them have something similar, which is the last three characters in the term, right? So as a service means it's basically a service that you can start anytime, you can stop anytime, you can scale up and down. For example, in the case of software as a service, common model is to have user-based pricing. So you can use salesforce.com, you can start using it anytime, and then you can have initially maybe 5 users, you can expand it to 10 users, and you can also come back down. From 10, you can come back to 5 users. So these are general characteristics of as a service. So all these 3 service models have similar characteristics as far as that is concerned. But the difference is in what is offered and who the audience is, right? So software as a service is for end users. So these could be people in your finance department, HR department, and so on. And they are concerned with using a software. They don't really care whether it's Java or Ruby or PHP. They don't care where the servers are. They're just concerned about using the software. Platform is for developers. The idea is developers want to focus on their applications. They don't really want to, or they don't have the time or the inclination to worry about the infrastructure. So why should a developer do things like backups or patches? So can we have a service where developers simply upload their applications, upload the new versions of their applications, and the rest of it is automatically taken care of, right? So that's a platform as a service. There are examples like Heroku or Google App Engine, and there are some services in AWS as well, which can be considered a platform as a service. And then finally, you have infrastructure, which is the raw infrastructural elements, things like compute and storage and networking services, where you get the hardware side, and then but you have the same service characteristics. You can start them, you can stop them, and you can scale up and down. So infrastructure is better thought of as targeted at system administrators, companies which want to have full control over their infrastructure. Here's a bit more information about these three delivery models. And now let's also talk about the deployment model. So what's a public cloud and what's a private cloud? So when the cloud concept took off, right, and these cloud services like AWS took off in 2006, and for many years after that, most of these cloud providers were what is called public cloud. So public cloud simply means that the cloud infrastructure is open to anybody can provision capacity in the cloud, and the infrastructure is shared. So multi-tenant simply means the infrastructure is shared. So on the same physical machine, you may have your application running and I may have my application running both on the same physical machine. So this is called multi-tenancy. I mean, there's no security issue because we are running in virtual servers. I can't see your application or data. You can't see my application or data. But the reality is both applications are running in the same physical machine. So this is called public cloud, where there's multi-tenancy and anybody in the world can access and provision infrastructure. Now, but after some time, as the industry matured and more types of businesses and companies and organizations started to look at cloud with interest, and also the cloud vendors like AWS want more people to come in, right? They want more customers. So what happened is some industries like banking or in the US healthcare, these are companies and industries which are heavily regulated, and also they're very sensitive to data privacy, data security. So, for example, banks would be very concerned about financial records, about credit card numbers, and healthcare, especially in the Western world, where patient records, your health records, for example, are subject to regulations which require that they be kept safely, right? So you don't want your health records to be out there in the world. So these industries are heavily regulated, and the government regulations demand that the data be kept in isolated networks, and the infrastructure be completely owned and controlled by these companies, these large healthcare companies, these large financial companies. So there was a problem because cloud is mostly about sharing, and these companies are mostly about not sharing, right? They want isolation, they want control. So basically then people start thinking about how do we get cloud-like capabilities, right? So everybody understands that elasticity is great. Everybody understands on-demand is great. Maybe this kind of pricing model is great as well, but we can't have public cloud because of regulations, because of data privacy concerns. Then this idea of a private cloud started to gain some traction. And the idea is we have cloud attributes, but the infrastructure is single tenant, which means it's completely for a single company. It's owned, controlled, and used by a single company. So that's what private cloud is. And then what happened was people realized, hey, this is good, but private cloud is too expensive because this sort of capability, both building this sort of capability, and also because there's no sharing, right? The infrastructure cost is high. So how do we get more benefits from the idea of cloud? So then that's why you have the idea of a hybrid cloud, where the thinking is, even in let's say a bank, there are many applications and many types of data which are not sensitive, right? So there's, of course, your account details, your credit card numbers are sensitive, and your core banking systems are sensitive. So those should be in the private cloud. But maybe the bank has a public website which is not that sensitive. Maybe they have a learning management system which is not that sensitive. So the idea was, why don't we have some on the public cloud and some applications on the private cloud? And we can also have some sort of interaction between the private side and public side, and that is called a hybrid cloud. The differences between SaaS, PaaS, infrastructure, MaaS, CaaS, okay, basically what's common between all this is these are services. All right, and how do we take care of data in public cloud from a security point of view? So basically, for example, with AWS, they have lots of security certifications. This is AWS, right? So they have things like ISO 27000, they have SAS 72. So basically a shared security model. So on their side, they will have to have proper systems, processes, physical security, network security, etc. So that's their job. And on our side, we will have ways of securing our application. So you have things like network ACLs, you have security groups, which are firewalls, right? You have to use public-private key pairs to connect to your server. So you'll find out that it's a pretty secure. Like I've never seen a security issue with my applications. I've never seen any major security incident with the AWS service. So going by the strict definition, private cloud should be hosted and owned by company. So Amazon will not have anything to do with this. This is your stuff. But like I said, there is something called virtual private cloud from Amazon. This can be a happy compromise because you get some amount of private cloud, right? So you can get some amount of private cloud, you can get network isolation, you can get greater security, but it's on AWS's data center. In VPC, you can also get dedicated instances, right? So there's no sharing of hardware. So that's also possible in a VPC. Of course, you have to pay more for it, but you don't own and control the infrastructure. That is still done by AWS. Now let's try and understand AWS a bit, because then only then can we start using it. So AWS is mainly an infrastructure as a service provider, but also you can now consider them to be moving in the direction of platform and software. Let's talk about AWS. So, first of all, a little bit of, I don't know, you may be familiar with Amazon.com, right? Amazon.com, the company, their CEO is a guy called Jeff Bezos, and AWS is a business. It's not a separate company. It's still a part of the Amazon.com company. And to understand or really understand AWS, you also have to understand a little bit of Amazon.com. And the way they work is their goal is to dominate the industry, whether it's Amazon.com in the online retail space or with AWS in the infrastructure space. So what they do is their style of working is they will start with a small number of services and they'll keep expanding. So initially they will probably have, say, infrastructure, but then they'll go into platforms, then they'll go into software, right? And they will go into any place which will allow them to become a single shop for you. So they'll try and give you everything you need, everything you ever need for your infrastructure and for your computing. So you can expect AWS to keep expanding its services the way Amazon.com went from books initially to then CDs and then to music and then to digital books, then to computers and stuff like that. And secondly, their whole model is that they'll keep reducing the price as well. So the price will keep coming down every 6 months or so. There will be newer and newer services, and you'll basically, you'll go to AWS for anything you need. So that's how they work. So why I'm telling you this is, I've seen this, I've been following this company for a long time, and I've seen this in action over the years. So initially started out as an infrastructure as a service company. So mainly they would give you virtual servers, they would give you some storage, right? They would give you some databases. Then now they have started going into platforms. So platforms are where you don't get just the raw capacity, the hardware, but you also get some additional services on top of it. So for example, there is a service called RDS, Relational Database Service. So you can run your MySQL databases, you can run your Oracle databases or Microsoft SQL Server on RDS. You can also run these things on EC2 instances. EC2 instances are basically simple virtual servers, like your VM virtual machines. You run your databases on EC2, but if you run them on RDS, what happens is RDS has a lot of built-in capability. So it can do replication, right? So it can do the primary, secondary replication so that you have higher availability. It can do automatic backups. It can help you with point-in-time recovery. So if your database crashes, you want to go back 2 days back, that sort of thing. It can do automatic patches for your database. So RDS is more like a platform. So initially they started on the infrastructure side, and now they are expanding on the platform side. So you have basically compute infrastructure, basically servers. You have a storage infrastructure, things like S3. Glacier is for very cheap storage, things like tape backup, stuff that you would put in a tape backup, long-term database backups, log files, etc. That's what Glacier is. So EC2, S3, Glacier, these are important infrastructural services. On the platform side, you have things like RDS for relational databases. You have DynamoDB, which is for NoSQL databases. Right? NoSQL databases are for highly scalable and fast database use cases. Relational services, you have NoSQL services. You have a caching service. Again, if you want to serve data, some data from in-memory caches. Right? So these are faster than other databases. So you have these other types of platforms as well. For example, you have EMR. So this is basically Hadoop service. So you don't need to learn how to install and manage Hadoop. You can simply click a few buttons and get a Hadoop cluster running, and then you can process your big data jobs. So EMR, RDS, DynamoDB, these are like platforms, and they are built on top of infrastructural services like EC2 and S3 and Glacier, right? So you have some infrastructure, you have platforms, but it's not only infrastructure and platforms. They also give you a lot of tools. So anything that you may need, right, which will make your life easier, which will help you become faster in your work, which will reduce your cost, they will also give you those things. So for example, there are some application services. Now, one example here is there's something called SES, Simple Email Service. So, as a developer, you might know that in your application, right, most applications send out emails. Let's say if you're an e-commerce company, you send out an email when you receive an order. When you dispatch the product, you send out an email saying your product is dispatched. When when the product is delivered, you send out an email that, hey, we have successfully delivered your product. So emails are part of all applications nowadays, and you need to send out a lot of emails. Now, however, what happens is managing your email servers is a real pain. Some of you may be familiar with this. So what can happen is you have to secure your email servers. They can be hijacked by spammers, for example. And then you have to maintain the reputation of your email server so that your emails are not going into spam, right? So these things are a little specialized. You need specialist knowledge to do this properly. And if you mess it up, your reputation can be affected. So for example, if your messages go into spam, what will your customers think of you? So these are sort of hard things. And therefore, what Amazon is saying is, why do you want to waste your time doing these things? These are undifferentiated. You are doing whatever your competitors are doing. Why do you want to waste your time on this? You focus on your product and let us handle the emails for you. So it's not just, so this is also, kind of a platform and kind of anything as a service. So you can use SES in your application with a very few, with simple integrations. Like there are APIs and SDKs available. With simple integration, you can start using SES and just forget about the headache of managing email servers. So these are application services. You also have other tools like for managing deployment and provisioning. So how do we know if our capacity is appropriate? Are we under provisioned? Right? Are users seeing slow performance from my applications? So then you have to have CloudWatch, which is for monitoring and logging of your infrastructure. Then you have identity and access management, which is for controlling access to your infrastructure. So your team may have many users. Some users have different permissions, right? Some users can launch new instances. Some users can only have read-only access. So you want to have a service which lets you control, authenticate, and authorize access to your AWS infrastructure. So there'll be lots of tools which help you manage your infrastructure in AWS. So to summarize, AWS started out as an infrastructure as a service, is moving into more areas like platforms, and their goal will be to give you anything you need to help you succeed in your technology products or services. And the prices are extremely cheap. The prices keep dropping, and there's also lots of tools to manage your infrastructure. AWS was the first mover. They have much bigger scale. They are 10 times as large as their competitors put together. So that means they are ahead, right? So they may have more services, they may have better features, and the cost can be lower as well, right? So public cloud is secure, it is cheaper. So the question is, do you really need private cloud, even if your apps are private, right? So you can do it, right? It's a special case of a deployment model, and basically, the idea is a cloud set up by a group of entities. So, for example, I have seen this in some form, right? Not exactly going by the strict definition, but I've seen universities. There's a bunch of agricultural universities in India who got together and set up a common platform. So what happens is you have some amount of resource pooling. So the cost per university will be lower than if each university tried to do it on their own. But it's not, the pooling is not worldwide like public cloud. So it won't be as cheap as public cloud. So basically it's somewhere between public and private. So a group of organizations pool resources. Okay, so now let's talk about the infrastructure, right? So the AWS infrastructure, and let me show you this on the website. So, okay, so this is the infrastructure, right? Basically the data centers and so on. How is AWS organized? And this is very important to understand because it has real implications on how you will use AWS. So basically, AWS has a list of what are called regions. So a region. The orange circle that you see is a region, and you can see there are regions in North America and Europe, and now recently the attention has shifted to Asia. So you have data centers coming up in Mumbai in India, and then also in China, and then there's an existing region in Tokyo and Singapore and also Sydney. So these are basically large data centers, and each data center is called a region, right? And there are new ones coming up as well. So the green dots, the green circles are the ones that are coming up. Now, the regions are basically the way you have to decide on a region, right? You basically have to pick a region for your application, especially if it's a production environment. So what you would do normally is you would pick a region which is closest to where your users are because of network latency. So, for example, if your users are in India, and if you picked a location on the US, let's say West Coast, you can see physically the distance is very large. So the network traffic, the nature of the network is such that the greater the distance between the users and the servers, the more the latency, right? So it'll be slow. So normally what you want to do is you want to pick a region which is closest to where your users are. So if your users are in India, pick the India region. And this India region is new, right? So normally what you would do is if you don't have a region in your own country, then pick the nearest one. So you would normally pick the Singapore, all right? Okay, folks. So that's it from me. Thank you. Bye.